Hello, my name is Sharon Vogel, and this is the presentation for my action research proposal. I'm under Dr. Robin Cole for this course, which is GED 689 for my Master's Research and Design. The title of my proposal is Experiential Outdoor Learning for High School Science Students. The area of focus will be the effect of experiential outdoor taught lessons on student test scores and student engagement. The significance of the study will be that it focuses on high school students. In my literature review, I came across a lot of studies that were about junior high students and elementary school students, but not a lot on high school students, so this will expand that knowledge base. Also, this will be really relevant for science teachers who may see a significant benefit in including experiential lessons throughout their units and the topics that they cover throughout the year. But it would also be useful for educators who are not in the scientific field because it can be applied to other subjects as well, like math and history and art. So the problem that I will be covering, that I will attempt to improve with my study, is that the students in my school are lacking the sufficient engagement to complete in-task assignments with sufficient depth. They are not engaged enough to participate in the discussions and during instruction to ask deeper questions. And too few of the students are achieving grades higher than 75% on their science exams. The purpose of this study is to explore the effect of experiential and contextually relevant science lessons on student exam scores and student engagement. In turn, this will illustrate the importance of integrating more hands-on education in science courses. To explain what experiential science lessons would be, that kind of teaching would include more hands-on experiences for the students, contextually relevant, as in a setting that would naturally be where these topics would occur. So for example, if I would do a geology lesson, it would be outdoors near rock formations, so that would be contextually relevant, but they're also relevant to the students. So the educator would attempt to make these lessons more relevant to a high school student. And they're also authentic. So by taking them to a setting that that makes sense, that you would, where you teach it. For example, we'll cover planetariums. So if the students are learning about astronomy, they could go visit a planetarium, which would be a relevant location. So in my review of the literature, I will cover three articles that I thought helped out with my understanding of this topic. The first one was a study done in Turkey, and it was for Turkish educators. And the educators' goal was to promote sustainability in the environment. So they took a course that was offered that would show them how to be more sustainable and how to teach their students that. Especially water conservation was very relevant, and it also, they wanted to show their students how to be more connected with nature, and that in turn helped with understanding social and economic and environmental values of the natural system. The second article was also in Turkey, and 10 Istanbul students visited the planetarium. They were in an astronomy unit at the time, and so it made sense for them to visit a planetarium, and they expressed very positive experiences as a result of that lesson, and they were also able to clear up some misconceptions they had about models. For example, models of the solar system are usually not to scale as far as distance relative to the size of the planets or even relative to each other. And so for them to go to the planetarium, they were able to see models that were more accurate or illustrations that allowed them to understand the solar system on a level that possibly they wouldn't be able to get from a textbook or a direct instruction lecture. And the last article I read that I wanted to share with you is one that was from a Colorado school that was already geared towards this type of learning, where they would often take their students outside and do the lessons outside from many different subjects, including science, of course. And they asked the teachers and the students and the parents what they felt, how they felt about this type of learning. And it was a resounding positive response that they believed there was an enormous benefit to including this type of education, and therefore being more encouraging for students and schools across the nation who could possibly integrate that type of learning into a typical classroom. It doesn't have to be a school that is just geared towards that type of learning, but you could actually see that in any kind of classroom where a teacher could include that in occasional lessons and in a unit, for example. So my 3 research questions are: what is the effect of experiential outdoor learning on high school students, science students' exam scores? And what is the effect on student engagement during these hands-on lessons? To what extent do students respond positively or negatively to experiential outdoor science lessons? So my methodology, this will be an action research type of study. I will be gathering both quantitative and qualitative data throughout the study. Now a bit about my subjects, my participants. I have 52 high school students that I will be including in the study. And they are in a life science course currently. There are 3 sections. So the 52 high school students are broken up into 3 sections. So their classes range from 18 to 20 students in each section. That will be important to note for the collection of data on the next slide. So the gender is broken up and it's actually perfectly split, so 26 males and 26 females. They will be selected because they are enrolled in this course, so that was the method in which they were selected and the course in which I am currently substituting for. Their ages range from 13 to 16 years old. This is a private Christian school in an affluent neighborhood of Southern California. So this is I will now explain the data collection process that I am planning for my study. So the way the curricula is broken down, each chapter is broken down into sections, and each chapter takes approximately 2 weeks to go through. So in my 8 weeks of study, the first 2 weeks will be the first chapter I cover, and it will be the baseline data for which I will use for my data analysis later on. So there will be no intervention those first 2 weeks. And then after that, the next 2 weeks will be the second chapter we cover. In that time, there will be the first intervention. The intervention that I'm implementing will be the inclusion of one experiential outdoor taught lesson or out of classroom lesson taught along the same topic line as the chapter that we're covering. Okay, so one experiential outdoor or out of classroom lesson taught per chapter after the first 2 weeks of my baseline data. Okay, so what's important to note is that over the next 6 weeks we'll cover 3 chapters, and every time we start a new chapter, a different section of the 3 sections of life science students will serve as the control group. That way, each section gets the chance to be the control group, and that will lend validity to my data by changing up which students are the control group and which students are experiencing that intervention. So that will take 8 weeks. We will cover a total of 4 chapters, approximately, depending on how quickly they get through the chapters, of course. All of the test scores will be collected throughout that time, so we're talking about a total of 4 tests because there will be a test given at the end of each chapter. They will be collected into Excel because it makes it easier for me to create charts and graphs later on. And the engagement part will be recorded in anecdotal notes during observations that I make during discussions in class instruction and direct instruction. So for the analysis of the data, I will be comparing all before and after data that will be made before and after the intervention. You will be using charts like line graphs, and I will be putting the from the debriefing, the answers, the yes and no's on how the students felt about the intervention. That will be put into charts. The observational notes will be analyzed for patterns. I will be looking for evidence of a change in the level of student engagement based on the anecdotal notes that I make. And then there will be the final debriefing at the end that I will gather the students and we will have a discussion, and I will ask questions about their general attitude toward the intervention and whether or not they would like to see this intervention included in their education from that point on, and that will be quantified in my analysis. So some ethical considerations, obviously and typically, as with typical with studies, I will be keeping the student's identity confidential for their protection. Limitations of the studies. Student engagement can be tricky to quantify because there are myriad reasons why a student would or wouldn't be engaged in a particular day. Variables that can't be controlled would include illnesses, lack of attendance during an out-of-classroom lesson, variable difficulty of the chapters, so depending on the way that or how the students were prepared for that topic or their background in the topic from previous grades can affect how well they perform or how much time it takes to cover the chapter. And then, of course, on test day, there can be issues at home or in their social life or physical illness, all that would affect their performance on a test. So those are some things to be conscious of. And that concludes my presentation for my master's research proposal. And thank you so much for listening.